This is 16.9, question number 3, the second of our divergent theorem problems. And this is another one where really volume comes in handy. They say let the volume be x, y, z between 0 and 1. So basically we've got a cube that starts at the origin and ends in the first octant at 1, 1, 1. Our function is this guy. It's okay in the x and y, but it's a little messy in the z. And then they want us to find the flux through all these surfaces. Well, once again, if I wanted to do it this way, I would need 6 surfaces, so I would need 6 different integrals. And then I would have to basically parameterize each one of those surfaces substituted in here in order to take the dot product. So let's not do that. The other side of this, of course, is the triple integral over E of f, or of the divergence of f dv. So that's what we want to do. We want to do this as a divergence problem. Okay, let's find the divergence of f and see how that works out. Again, the cross products, the dot products of the 3 components, it's going to be d dx, that's 2y, and remember this produces a sum. It's going to be d dy, that's 3x, and it's going to be d dz, so it gets rid of the z and it's just e to the x plus y. So that's not too bad. That's the function that we're going to end up integrating. And even though this isn't pleasant, if you just view it as e to the x times e to the y, you can see it's pretty easy to integrate in terms of x and y. Okay, we're going to do this then as a triple integral. There's no z, so we're just going to integrate this. All 3 are 0 to 1, so order doesn't matter. Our integrand is 2y plus 3x plus e to the x plus y. And that's dx, dy, dz. And once we do the work, we end up with 5/2 plus e minus 1 squared. So it's not too bad looking in the end. Remember, you want to avoid the divergence theorem of actually doing the flux unless the surface is a single surface that's simple. And it won't really be a single surface that's simple because it's got to be a closed surface. And a closed surface means lots of directions. Unless it's a sphere, that's really the only time I would ever do the dot product, or excuse me, the flux side of the divergence theorem.